Welcome to the last talk before lunchtime. Kunvirod actually did a lot of challenges around data science, and actually we'll be talking about how we can help him actually getting the data that he needs to build his model. Right? Data is the new gold. The new oil, right? We heard this back in 2006, right? But without a doubt, this phrase has been driven because of the increased adoption of the internet. People were starting to interact with companies online, so companies now have access to more data than ever. Then, in 2007, Apple released iPhone, which likely is the turning point that gives us to this era where everyone has an internet-connected terminals in their pockets, right? So now, we are generating data as we walk, as we eat, and as we sleep. With this amount of data being generated, companies now who have mastery over data has an unfair advantage over who don't. In 2020, McKinsey Insights has published that data-driven companies are 23 times more likely to acquire customers. They are also 6 times as likely to retain their customers, and as a result, being 19 times as likely to be profitable. In stark contrast, however, Monte Carlo survey earlier this year has highlighted that data professionals are spending a whopping 40% of their time doing data quality checks. And actually, drilling down a little bit more, you'll see that it takes around 4 hours for data professionals to find out when something goes wrong. And it takes them on an average 9 hours to fix them. And they have this kind of incident, say, 61 times a month. So you can see how quickly this adds up, right? It is so bad that the people who respond to the survey actually cited that their company are impacted, say, like 26% of their revenue are being impacted by bad data quality. Right. This links to Kunvirod's talk earlier that in order to have good insights, you need cleaner data. So now that we see the importance of investing in data, let's see how we can build data platform right. We'll start by going through the kind of problem that data projects might face, then go over the design strategies, the 5 pillars that will make all data platform, that we should consider, and then show you a glimpse of what a data platform might look like, and finally, talk through the steps that will be crucial for you to start building your own data platform. So, what kind of problem does data platform face? If you worked on a data project before, this scenario might be too familiar for you. You're working on a data project, you spend most of your time cleaning your data, and you have an excellent model or dashboard that you are ready to present to your stakeholders. And then you just go to sleep, and then wake up in the morning, and the code no longer works. Right? You spend the entire day to find out that one of the 30 data sources that you were pulling from changed the schema or was missing time-sensitive data. You could be pulling from NoSQL. You could be pulling from SQL. You can be doing getting web scraping data to help augment your model. But things change because, the world changed. It's inevitable that your upstream system can change as well. And things can just spontaneously go wrong, and then you have no data to work with. So even more, right? If you are doing machine learning projects, like some data project might even require working with unstructured data like pictures, document scans, voice, or even video streams. You might need some special hardware for that. You might need some special libraries for that. Now, how do we deploy to production and make sure that everything works, right? And some system might be even generating terabytes of data in an hour, right? How do we process data at such scale? Comes to our talk. Let's look at what are the things that you should consider when you are building your own data platform. we present to you 5 pillars: scalability, deployability, observability, testability, and compliance. Let's take a look at the first one, scalability. The part 1 of scalability is availability. You have to ask yourself how critical your process data is to the business. Because the more critical it is, the more cost you need to spend to make it work right? So is your business asking for what? A report? Is it an interactive one? Who are your end users? What are the expectations? Right? And when things go wrong, can you rerun your pipeline to generate those data again? And what is the maximum acceptable amount of time that they can tolerate for the restore? What is the maximum acceptable amount of data loss that you might have to take into account? Part 2 of scalability is growth. Simple question is, can it handle 10 times more data in a reasonable amount of time? Because your data platform that you build will be growing over time. There will be more users, more use cases, and more data to process. So it is very critical that the data platform that you're building for your organization has to be able to scale. But if you are really sure, right, that your use case can always fit within one machine, that you can always afford, then you don't have to worry too much about scaling. Again, keep it simple, stupid. The more that you invest, right, the more complexity you get, and it can snowball really quickly. So now that we talk about those tech stack, right? Let's see. Next thing is for horizontal scalable technology, you can usually just put more compute and then it will scale. But when you're starting to get diminishing returns from just throwing more compute power into it, then it actually pays to sit down a bit, think about the data, and find if you can partition it in a way that helps you scale better. And it's also likely that your business does not need the whole history to get an insight that you want. So having a lifecycle tracking in your data platform can help your data size be manageable and storage cost low. Last part of scalability is data freshness. Does your use case require process data to be ready in seconds, minutes, hours, or days? If you're using machine learning that you want to have a real-time recommendation engine that responds to people doing some live events or festivals, then yes, you might need something that can respond within seconds, right? And when you do that, you need sophisticated things. But if your use case is just generating a report, maybe you might not need a big data platform to do that. You can just go with the simple flow that we always know, just dropping files on the folder, do a cron job, and then extract some insight, generate reports, send emails to stakeholders. And that could be it. So the key takeaway for scalability is it depends. The more you ask, the more expensive it gets. Next to the second pillar, deployability. It's totally fine to do your POCs in notebooks. Do it locally, do it on Colab or any other cloud services. But if you really want to make sure that your workload works across environments, then you need to have confidence in deploying. You need to automate your pipeline. So we do take the same principles as DevOps. Right? We do continuous delivery. We have to make sure that whenever we change something, we can see it work in all the environments. Right? So how do we do that? We plan, we deploy, we evolve, and we do it often. So if you are using infrastructure as a code technology, then this helps us significantly because we can define our stack declaratively. Infrastructure as a code will take over the configuration that we write and then generate the desired state for our infrastructure. This actually has a very amazing benefit because we are now writing code. So it allows static code analysis tools to run tests against it. Now, even before we actually make our infrastructure live, we have faster feedback to see how much it's going to cost. It is going to break certain compliance rules. For instance, if you're using Terraform compliance, we can actually test our deployment like given all object storage buckets, then they need to be encrypted. Or do something fancier, right? So now that we can see that we can scale, we can deploy with confidence, allow me to pass the stage to my colleague, Manisha, who will go over the second half of the presentation.
Thanks, UP. Okay. So now we have talked about two most important pillars, which are deployability and scalability. I want to talk about the third pillar, which is observability. Okay, so what's observability and why it's important, why we are talking about it? So to me, observability means keeping track what's going on in my system, right? That's what observability. We are making enough observations and logging them. That's observations to me, right? Observability. And why? The answer to this, I feel like it is in case things go wrong, right? We want to debug, figure out logs, what went wrong, where it went happened, and then how do we solve it? So in a nutshell, it helps us identify where things are going wrong and how do we troubleshoot and fix them. That's why observability is important. And when we talk about data platforms, it's not just the applications, right? We are doing more than that. We are not just running a job once a day, which is going to help me figure out where things are going wrong. What kind of things can go wrong? To me, it's like anything can happen with my infra because data processing runs on cloud, right? That's why it's important. So we need to ask all these questions when we are thinking around building a data platform, right? It's not a functional requirement. That's why it gets crucial when we are thinking of setting up the rules of the game, right? That's why we talk about it. When I talk about observability, it includes monitoring, it includes analysis, it includes SLA tracking, it includes auditability as well as alerts. Everything which you are dealing and seeing in the system happening, right? That's what you're tracking. So as I was saying, so it doesn't involve only the application, it involves more than that. What's all that? Since in a data platform, we are processing data. So one of the aspects which we want to observe about is data. How is the health of my data? We may be getting data, okay, fine, but what about the health? Are there any too many nulls coming in? Are there any too many schema validation error happening, right? What about that? So that's what we do and measure the data quality and monitor and create alert on top of it. Similarly, infra, we are hosting our services onto the cloud, right? And we are scaling when the data is high, we are downscaling when the data is low, and then we are doing all those sort of things. But we also need to make sure that what is the CPU usage? What is the RAM usage, right? Those kind of things come under observability for infrastructure. And then accordingly, we also talk about other issues which might come in. Maybe integrations are failing, the data is not arriving, data is arriving late. So those all comes under observability. It helps you track when things go wrong. And the next part under observability is auditability. Since in data platform, you might be ingesting sensitive data. And I feel like when we are dealing with the sensitive data, we need to make sure there are enough audits. Because when a data platform is being built, we are not just talking about what data it is, we also need to make sure it is handled with care. So the system, who is accessing, what time, from which location, which IP, what sort of services are interacting, not just human interaction, all that comes under auditability. And hence, it becomes a baseline for our alerts. In case things go wrong, right? That's when it helps us identify what are going wrong and how we can tackle it. So this is the one of the most important pillar. And now we move on to the next pillar, which is testability. So how we can be very sure when we are going to production, right? The code is working, the data is going to come in and be there with ease, right? We know automation is the key when we work on any software. But when it comes to data platform, again, there are a lot of moving pieces, right? It's data ingestion, data processing, data serving, data analysis, data access, every part, right, needs to come together and work in smooth file, right? So we are talking about testing, right? We are testing what? We are testing our infra, right? We are thinking, okay, the infra is up and running, but will it work together with other sources and sinks? There will be a lot of data sources. There will be a lot of data sinks, right? They all need to come together and then interact. So that's when we talk about integrations. When we are taking anything into the prod, I have seen that most of the time we build things, but in prod they fail because we have not done in the pre-prod or the lower environments, those issues were not even thought about, right? So that's why the testing matters. Similarly, we need to test around the data performance, how much the data is going to be queried, right? So in case we are doing performance, okay, my data is there, sitting in zone A, where I'm moving to zone B, it takes 5 minutes. That's good. I'm happy about it. But I also need to make sure when data lands in zone B, someone is going to use it. How long it takes for them to actually use it. Maybe they query the data and then wait for 1 hour. That's not the part I thought about. So we again need to think around the testability, right? And then make sure that everything is measured right before going live. So that's why the testability is also another important pillar. And we also have the compliance as the 5th pillar. So what's compliance? Compliance to me is, are we safeguarding, right, our users from the malicious actors? To me, it is security. It is making sure the governance is in place. So when we deal with the data, there's a PII data, right? And then especially in all my personal information, my name, email, my address, my mobile number, my marital status, everything is maybe someone can identify. So when I have the responsibility to build a data platform and I'm building from scratch, compliance is the very first thing which I don't want to be in trouble later. Because we know with great data comes great responsibility, and especially when it's PII. So when we are thinking around setting up the platform, are we asking all these questions to us or not? So are we safeguarding the data correctly? Is it going to be accessed by everyone, or we need to put a restriction on place so that only a limited set of users, or maybe not even that, maybe just a system will access the PI and not any human eyes can see that. And then is it going to be used for ethical purposes, right? It has to be a responsibility used. Otherwise, it can lead to other problems. Is it up to date? And then there's an important point around the CCPA, GDPR. What compliance it needs to adhere to? CCPA, California Consumer Privacy Act. GDPR, we all know. HIPAA, what also compliant it needs to cater to. If we don't think of these compliance in the very beginning, right, then when we go live, I have seen from my experience, we are in a situation, we are in violations of these compliance, which can land one organization in trouble also. Imagine a use case. You are running a gym organization and people are coming to you, they are signing up, then, okay, they paid for 6 months, and now they are not interested. And that's what happens to all of us, at least to me. I don't go, I just pay. And then later on, I'm getting emails continuously, okay, please come back, and these are offers running up, and we want to have you on board. And one day I get fed up. Why I'm getting all these emails? I am not even a member. My membership got expired 6 months back. Why are targeting me as on marketing, right? Why? I want you to delete all my data, stop sending me emails, and even delete my data, because I just want to. That means there has to be a provision that you are compliant. So GDPR or CCPA says the one curious point is right to be forgotten, which means removed when requested. So in case you don't think about these compliance in the very beginning and you just build a data platform and you have data everywhere, my information sitting in every zone, raw, refined, processing, transformation, sending to so many parties, how many places will you go to remove my PII? It's unimaginable. It's not solvable. in case you think of those things later on. So how do you make sure these things are put into account when you're starting from scratch? Otherwise, being in non-violations, right, of these laws, I don't prefer that on to be on that side. Otherwise, it could be very challenging task to solve one particular problem. And this is just one thing. There can be many of the compliance things which are important. And then there's another aspect of compliance, which is data security. So when we say data is secure, how do we define it? Okay, data is in rest. It is sitting somewhere. It is encrypted. Good. Data is in motion. Why it needs to be secure or encrypted even in motion? Because I feel there are cross-border restrictions. We are using cloud. We are deploying something in maybe in the Europe, in the US, or maybe somewhere, right? But my data should not be moving out of my boundary. Those kind of things. Even when internally behind the scenes, sometimes just the cloud providers move out on their zone, and then they give you back. Sometimes you don't even know it. So it's better to have encryption in place when even you are moving the data around from different places, one place to another. And then the other point is, when it comes to security, is RBAC, role-based access control. So you have data, you want to make sure people are accessing the data they are qualified for, right? So authentication, authorization, everything is there, but then after just you get to the data, right? But you should be seeing maybe only that particular row or only one particular column. Maybe I cannot see the other people's email ID, but I can see there's one another people who is going to the gym, right? But I cannot see his email or ID, right? Maybe I have everything, every possible access, but that's how you do it. That's how where comes in the sensitive data masking. So there are different ways these can be achieved using maybe creating a group. You add some people to group who has privileged access and the other are normal regular user, and then you can mask it on the fly. So that's what, to me, is data security. And the other point is protection against the data exfiltration. Data exfiltration is maybe moving the data out of your platform to your personal space or somewhere else. Maybe someone who is accessing your data, getting into the platform is authorized to do anything with your data. They can log in, they can query your data, they can even view the PII. But are they allowed to move out the data of the system boundary? No. That's how you need to think of those boundaries. That's how you protect against the protection against the data exfiltration. So your network boundaries, ability to download the data and then move it around to their personal accounts or local laptop, those things are also crucial. So that's where the compliance comes in. And then one of the biggest piece on the compliance is data governance. We know all these things in bits and pieces, which I just talked about, is part of governance. But at the same time, when we are saying we need to secure our data, we need to put it under the lock, right? And then, but we at the same time, we also need to be very comfortable. The users who are actually qualified to view the data, they are able to discover it, and they are able to use it in some catalog. Keeping all the compliance met. That's the crucial thing in governance. So in this diagram, if you see, on the left, you have the producer who are sending the data, creating it. On the right side, you have the consumers who are going to consume the data. In between, there's a data landscape where all the processing, transformation, lineage, everything is happening. And then there's across the board, on the top, there's a governance framework which is taking care of, okay, who can write in the data, which zone the data they can write in. On the consumption side, there's again the same framework is taking care who is going to use the data, at what level, what granularity. So these things are taken care across the board by the common governance frame group. So these things are difficult to implement, but yes, they are important. Governance, there are many tools which they can do it on the clouds, and even in the open source community, there are tons of tools. But which suits your needs, that's when you need to start exploring and then come up with the corresponding tools. Because this is not a functional requirement. This is one of the cross-functional requirements we are talking about. Okay. So talking about all these 5 pillars, scalability, deployability, testability, observability, and compliance, we think around all this, what does a data platform might look like? Will it change or not? Okay. So this is a reference data platform architecture I have. I see on the left side, we have data producers. On the right side, we have the data consumers. In between is all the place which we call it data platform. That's where all the magic happens, right? So we have data coming in from sales, inventory, CRM, mobile apps, social media, Facebook, Google Analytics, whatnot, and some third-party integrations. And the people who are interested in their data, maybe someone wants it daily, someone wants it at every hour, every second. Those are data analysts, BI developers who are doing reports, data scientists, business user. So how do we move the data from that zone to this zone? That's what we call data platform. And in between, you see the gray boxes. That's the building block of the data platform. There's a storage layer, there's a processing layer, and then on the top of that, there's a serving layer, which eventually the end users or consumers, we call, they are going to come and query. But I don't see the 5 pillars which I just talked about in this. I don't see them anywhere. I don't see observability or maybe testability. These are not functional things, or these are not even the data components which you see in these boxes. Those are the things which you need to take care at every block. Let's talk about the storage. When I talk about storage, the first point we said, it's scalability. You will add more storage, right? Because you are adding more data. Storage can be file system, database, NoSQL DB. So anytime you are thinking around building maybe the raw data zone, curated or analytics, you need to make sure you're choosing the right DB or right storage layer which can scale as your data volumes will grow over the time. In 1 year, you will be dealing terabytes. In 2 years, you will be dealing petabytes. So that needs to scale. Then there's another point, deployability we talked about, the second pillar. As we know, we'll make changes, we'll make improvements, we'll always deploy. We are an advocate of CI/CD, continuous integration, continuous delivery. We'll always deploy sooner, build more features, onboard new integrations, not just 5 or 6. Slowly, your platform you will see tens of integrations available, 10 types of integration, and the sources can be hundreds. And then you will have deployability needs arising every now and then. That's where the deployability is again important in the storage layer. And then there's a component around observability. That's the most crucial part. We said observability is what's going on into the system. So in terms of data storage layer, I see observability, okay, what's changing in the data? Are there any too many excess happenings? Are there too many excess happening from outside my region? People are coming in and trying to access PII data. Or maybe the system or the DB is not performing up to the mark, right? Those all things are observations which I need to build upon and come up with the monitoring so that my data platform can be successful. And then fourth point, I talk about testability. Again, testing matters because the data is coming in from point A and going to point B. So testing in the lower environments before you go live, where the integrations are working fine, coming right on time. You do all the dry run in your lower environments before you move. In case schema changes, what happens? So that testing matters even at the storage layer. And the last point, I talk about compliance. Who is accessing what? There has to be right classification. I know the access has to be tightened, that PII is secured so that you are not under trouble, but then the classification should be right. Not everything is right, should be classified as PII or sensitive. So those classification rules and the policies which someone manages in the governance team, they are put on top of data. So that's where I see the fifth pillar also is coming in. So every component, be it processing layer or serving layer, every component has to adhere to those 5 pillars, and that's how you create a platform which I can actually work, and you'll see less failures or less chances you are getting into solving or debugging the issues if you think of those 5 things from the very beginning rather than having an afterthought. Okay. So what are the summary from my perspective? So I'll put it from the process perspective. I'll put it here, evolving architecture. As I was saying, that architecture will be very fluid. Maybe one data source is sending you files. Tomorrow they say, okay, another data source B comes in, okay, I'll send you data from an event stream. You come and consume from Kafka. And the third one comes, okay, I'll expose a REST API. Fourth one says, no, I have a DB, come and fetch in. So everything now and then, a data platform has a responsibility where they talk about handle with so many systems, different types of system, where that architecture keeps on evolving, keeps on changing, and then based on the requirements, you also change your processing, your tools, your tech, everything. So first thing is evolving architecture. The second point is test-driven development. As I was saying, testability matters. You test your infra, you test your data, you test your quality, you test and also do the data profiling. So being TDD helps to fail early and even succeed early in future. Refactoring. As the changes happen, rather than writing everything again, we believe in refactoring could solve a lot of the things and then have you lesser tech debts as a tech person. Pair programming, rather than spending time a lot of reviews on the code later on, so that there is no memory leaks or some other things which are being just left over. Doing pair programming helps in figuring out the root causes early, because if one mind is not enough, the other mind can catch in. Continuous integration and automated deployment. I'll talk about both together. Any change we are doing, any problem we are solving, we want to do it in continuous sense. We want to build CI and automated deployment. Why? Because we are not just talking about processing jobs. Our infra is also a part of build pipeline, our deployment pipeline. We are setting up our infra first using Terraform, CloudFormation, then Azure Resource Manager templates, and then first you set up your infra, and then after that pipeline, you set up your code. So that's why the CI/CD gets crucial. And then you have functional testing, infrastructure as a code, more and more deployments, use CD. Maybe your features are not ready, toggle them, put them behind a flag, and then serve them. Because maybe you are deploying something, but the other feature is still in play. So these tiny things can help your life when you are a data engineer like me, and then they can help with the smooth deployment cycle as the changes happen. So to summarize, what are the priorities I need to keep in mind what we just talked about? Automate infrastructure and deploy early. We want to automate more and more, be it infra, be it code, be it test, anything, right? We want to automate everything and deploy as early as possible. We want to focus on building capability over just solutioning. If I'm getting a data from a stream-based system, I want to build it in a framework, which later on, in case I get data from another stream-based system, I don't do it from scratch. I have a capability or framework in place, rather than creating anything in more generic approach. That's why we say build capability over solutioning. Do audits, threat modeling, and security reviews. Internally, the threat modeling exercises have helped me, because when we build up platform, sometimes we struggle with networking. At least I struggle. Which system is open, which port has left open, who can get into the system, all that pen testing. Frequent threat modeling exercise helps to make sure that there are no loopholes into the system, and then hence you are mostly compliant. And then monitor and alert if the data goes to, because data platform is all about data, and someone really needs it at particular hour of the day. Someone wants it at 12, someone wants it at every hour. There's a timeline or SLA you have agreed to or committed. So make sure, in case things are going wrong, you are alerted right on time. You're not just observing the job, but also the data, why data has not landed. Build an alert on top of it so that someone can come in and start looking at it. And then performance benchmarking. Not just from your pipeline perspective, how long the time it takes for moving the data or transforming the business logic runs from raw to the curated zone. That's not enough. Performance benchmarking should be driven from the consumer perspective. Okay, the data is there, ready to be consumed. You have clubbed 4 data sets, you have done joins, you know the right modeling, everything is there. But consumer is complaining, my queries are failing, it is not even passing after 5 hours, what do I do? So performance benchmarking from consumption needs matter, and keep an open mind for hybrid tech stack. So open mind to hybrid tech stack, I would put it in 2 ways. One is cloud provider specific thing. You can go with maybe catalog or maybe Purview or maybe Glue in AWS. Azure has Purview. Or maybe you can go with something open source, Amundsen. So your solution, if you're using Azure or maybe you're using AWS or Google, it doesn't mean you will use everything from their own sub-bucket. It can be a combination of cloud-provided cloud tools and plus some cloud-agnostic tools. Like maybe I'll use Azure Data Factory for orchestration, if I'm on Azure. But at the same time, I'm open to explore Apache Airflow for orchestration. So this is one way I put hybrid, because what suits my needs, what is cloud provided and cloud agnostic. And at the same time, there are scenarios when one cloud needs to talk to another cloud. That is also a hybrid thing to me. Maybe you are using, your infra is on Azure, but you are interacting with setup, or you are, due to some reasons, you also need to host some S3 bucket and interact with it. So that different clouds coming together is also hybrid to me. And make the data governance the first-class citizen, because I have seen when the governance is not there, the challenges are very hard and difficult to solve. Your data is lying all around, as I was giving example, and you want to delete or anonymize one data, one row. You don't know which all places to go in. There are so many backups sitting in so many places, so many forms, where to look at. So make the governance, or the data governance, your first-class citizen. Don't leave it an afterthought. And then, and last but not the least, is the test your integrations, your source integrations and sync integrations, who are going to be consumers and producers. They matter, because if they don't work in real life, all the effort put in development is not going to be very useful, and the journey will be very difficult. So these are the priorities or the summary from what we discussed so far. And now, in the end, I have the self-service data platform, which is like a next phase to the data platform we call data mesh. So we talk about how to make it self-service, more domain-oriented, more contextualized with the data needs, a federated data governance. I know these are all heavy terms, but I think the next talk, post-lunch, will help you clear what is data mesh and how they come all together. So yeah, that's all from my side. Thank you so much.